Welcome to the channel. Alright, so we're currently looking at the readouts. Well, hold on just a second. There we go. The readouts of our batteries. Our batteries are currently at about 1.85. Both of them are. We've been going for about 24 hours. Well, I mean, when it reaches 4 o'clock, 4:20 today, it'll be 24 hours. And in the meantime, I'm going to make a more Bedini style bifilar coil radial wrap. It's just going to be a normal coil with 2 strands, except it's going to be 24 and 32, and it's going to fill the whole bobbin. I'll tell you how many turns it is when I'm done doing it. That kind of thing, you know, just go until it's full. I think this blue coil, I was using it as a resistor. It has 856 ohms of resistance. These are my new batteries. And they're moving right along. I've changed it to 10-second cycles. Well, it's 20-second cycles, 10-second intervals. There we go. So I'm doing the double relay again, and each battery's at about, this one's almost at 12.9. This one's kind of around the same. It's at like 12.7, 12.87. Pardon me. I've changed it to 10-second cycles. So every 10 seconds it's going to switch which battery's drawing power from and which one's charging. Got the trifilar coil kicking, got 30 gauge trigger, got a 20 and 22 gauge at 730 turns, so 1460 turn coil. You know, it delivers some power, immediate power, being a 20 gauge, 22 gauge, and then it also is, you know, almost 1500 turns, so there's some inductance involved with it. I'd have to say it's probably maybe 20 layers, 25 layers, maybe more. Like, it's got to be more than that. Maybe 100 more than that, like 125 layers. I don't know. I went to and fro quite a few times. The way I wrapped this was in a traction phase, so you go from beginning to end, and then you go back to the beginning with like 1 or 2 turns max, and then you go 150 turns again, and 1 or 2 back, and 150 again, and 1 or 2 back. And you keep doing it like that, and that way you have 2 very distinguished sides of the coil, very strong north and very strong south. So, I mean, that's the way I wrap this one. It's pretty good. But it is only 1460 turns. So I was going to make a 24 gauge and a 32 gauge. 32 for the trigger. See, I kind of want to do a 30 gauge trigger because it's really smooth. And maybe even a 26 gauge trigger because the magnets will generate enough electricity for that to work. And it's very easy, so maybe even a 26 gauge trigger, but a 24 gauge drive. Just a little bit more on the amp draw, a little bit more speed, but And then, you know, ultimately, but I have to get more wire, is 26 and 26. So the 26 drive and 26 trigger. And that makes sense. It does make sense. I just like experimenting. It makes a lot of sense, though. I have this coil off to the side, gathering. Right now we're putting it through a bridge rectifier. And it's I attached it to the output of the SSG. Since there's a diode preventing the energy from flowing back. Hello? There's only one way for that energy coming from that coil to flow, and that's to the battery. Whichever battery is being charged at the time will receive that extra boost. And it's not much. It's a 32 gauge coil. Granted, you get a lot of voltage, but without a cap dump, you're really not getting much. So I've got a comparator circuit that I'm willing to try and figure out here. So this is part of a cap dump. And I believe that if I can make a cap dump and attach it to this coil right here, the blue coil, every time like a useful bit of energy gets gathered up, it'll be sent to the battery. And then I could also hook it up to this, because this is a cap bank with 4 bridge rectifiers. So each one of these rows has got its own cap in the front and a bridge rectifier, and then 5 capacitors in a row. And it comes out all together on this side. So it is literally a scrubber filter thing. But it takes AC and turns it into scrub DC. Slightly above the line. Well, it depends on how much you put into it, actually. I think these are 10 volt capacitors. Alright. Oh, we gotta try this permanent magnet thing right here. Alright, so I can feel that resistance, right? It's bad, right? It is bad. But look. It's like I want to stop it and start it again, but it's going. Oh, there we go. We go around one time, I think. Alright, now we'll just give it a little bit more of a nudge. So what we're doing here is all these are facing south, right? All these magnets on this rotor are facing south. So we got a north, all these magnets here are facing north, and they're going to attract it. And we got a ferrite core in the middle of this electromagnet, which is not plugged in. Okay, so I'm just using it to hold the core there. So it gets attracted to the iron, and then onto the next stack of magnets, which is going to repel, and it's going to push it along. It's already a flywheel, so I mean, it's just like a demo. You know, it's definitely can do this even better without the magnets there. But as you can see, the setup that I just described is happening. You can see it happen in real time. It's like, so yeah, it does something. Is it perpetual? No, that's not the objective. Can you get it? It's just a permanent magnet motion. It's not even a motor. You could, but I do want to have like 6 more setups like this. or 5 more and have 6 go all the way around and see what kind of torque we can get from it. Because you can see there's a little bit of like, once it crosses the threshold of the iron, there's a little like kick where it lets go and gets pushed. But I was just thinking it would go from strong pull to medium pull to push. And then it would go, like, or keep going, at least for a little while. And with all the resistance on there, it's, like I said, it'll move better if you just take them all away. But the fact that it's still moving, with all those magnets being there, says something. Hello, hello. All right, so yeah, the update. The little motor over there it's been running for now 24 hours. And we have about a 0.15 drop on each battery, or not even that, like a 0.12 drop so far on each battery. So before this is over, I'm going to probably change rotors, and I'm probably going to change coils. I want to make a new coil that's going to cost a lot less energy to run and generate a lot more energy than this one does. That just makes sense. This is just the best one I have right now. And it's not bad. I mean, it's been running for a day now. And it's used very little energy. But I know it can use less. I know it can do better than it's doing by a long shot. So, Mike, what's going on, bruh? No, I'm just playing, man. How you doing? Sorry, I didn't get back to you the other night. All right, so we've got attraction, and then we've got attraction that's not a magnet. So it's just, this is attracted to it, but it doesn't have any pull on it. So we go from a pull to an attraction to a repulsion. Just like that. So like if I whip this, which I'm not going to do, I'll just do a nice little gentle one. The arrangement that I said will affect each magnet no matter what the frequency. It doesn't matter. And the reason I have it like this is so the spacing, the magnets on the wheel are 40 millimeters, right? So when it comes in, and by the time it's on repulsion, it's not attracting by the magnet anymore. It's just the ferrite. So there's more of a chance that it's going to get pushed along. But it is very much dependent, in my opinion, on the size of the magnets, not necessarily the strength. I mean the actual physical size of them. But I believe all these are N52s. You can see in a shaft how it's jostling it around. So I was thinking about having one of these stator effects, and the ferrite core here is wrapped in aluminum, so it's very focused. And when you use it as an electromagnet and you actually plug it in, it's got a pretty wicked effect, even though this is only 11.4 ohms 32 gauge. Yeah, I used on my, they're over here actually, on my current ferrite magnets. Except for the ones that are working as maglevs right now. So this rotor, I put my ferrite magnets on it, and it's a little, 120 degrees, and I already got 2 coils made for it. Out of 24 and 32, and I'll tell you what, man. When it'll move the coil into the right position, and then you should remember what that position is, because this thing will cut glass. it moves so fast just with one of these coils on it. And then you got to decide whether you're going to go parallel or in series with the coils. They each have their own triggers, so they can go parallel if they want. Heck yeah. So this is it in reverse. Haha, just kidding. But yeah, no, not really. The bearings are like so smooth on this, and it's actually a straight shaft, so I'm all thrilled about this one, because it literally, you can put it right through this thing. That's why it's straight, See, as you can see, it's gotten into a rhythm. It's slowing down, but it's starting to click like like it's working. It doesn't really shake when you got a flat surface. And this board right here, this pegboard is not flat. But it's so smooth. It is so smooth. And you're right, man. The ferrite magnets are, they got their own benefits, for sure. So yeah, man. All the above. So this is just a ferrous core. It's not a magnet. It's just magnetic. And it's made out of the same ceramic, except it's not magnetized. I'm pretty sure, anyway. It looks like it is. I can't really tell. All I know is that it's a ferrite core. So I'd say it's not like a soft iron core, but like still iron. It's got just the right amount of pull for what I'm trying to do. And then these are nickel magnets. I'm pretty sure they're nickel plated. So they're slightly shinier than all the rest of my stuff. It's kind of weird. Oh man, see, what I want to do is I want to get it going, right? Get this rotor moving, and have 2 coils picking up, and then have this in here in the middle. See how easy that was. Woo! And then you get it going and spin this, and that'll start to spin, and then you could have 2 more coils. I just wonder if I can put 2 pickup coils in there and then still have the ferrite move the disc. That'd be sweet. That would be... Yeah, consider joining or getting a membership though. And if you got the spare cash, that would be awesome. Could move this along. You know, get a fair amount of transistors. That's a very practical purchase. Sweet, man, that is awesome. So is this still moving? Yeah, that's still moving. So you put a little bit of force behind it and you're going to get a bigger return. And that's why I put them there in the first place, you know. You get a little bit higher frequency and you're going to, even though it's going to stop it, I'm not trying to make it go forever. I don't care about that. I don't care about it even being exponential at this point. It's permanent magnet on permanent magnet. We're just trying to get it to move a little bit. With the setup that I have, not getting into a whole new library of setups, which I may do. I mean, if somebody points something specific out to me, I'll probably check it out. Like Howard Johnson, I've checked that out. There's like this stator out there that is monopolar pretty much. With the proper yoking and all that stuff, it becomes a monopolar stator, which is, you know, beneficial. I'm wondering, yeah, because right now, the transistor that's in there is the only one that I have that works. It's got 460 resistance, 460 ohms. It should be right around 640 though. I checked it out with the pot, and it works so much better with an actual resistor in there. I mean, it works good to figure it out, but then, you know, eventually you should switch it out for a resistor. Just all the things you got. You don't have to. You just got to remember to reset it pretty much every time you start it if it stops. And a couple other things. Here we go. But you find out what the resistance that you need is, and then you get the equivalent resistor. Of course. But anyway, using that pot was pretty fun. I know that it's a little bit over the halfway mark, so it's right around 600. 550, 650. But I got 460 in there right now, so we're probably drawing a little bit high for it to be a really long ride. But like I said, I'm going to make that other coil, and probably by the time I get all that other stuff done, I could probably purchase a resistor or make a coil resistor that is 650 ohms. Like this one right here is 856. Big blue coil, 856 ohms. Yeah, there's this other coil I have in here. Like 400. See this one right here. This is like, don't know. It's in the 400 range. So that one, that's so not right though. Well, maybe, I don't know. This one feels really tight. So basically, I can use all these different coils as resistors in the resistance slot. This one right here is 160. So this coil right here will provide 160 ohms. It's 32 gauge, 1500 turns, wrapped around the outside of this thing, so it's like a big ring. Yeah, this one's pretty cool. I used it for the trigger coil in my toroidal motor. But, you know, I moved to the ferrite magnet triple banger, the 120. But that's a 120 motor too. It's all of its coils are aligned in 120. And it pushes a big rectangle magnet. So there's two sides to the magnet, north and south. But there's 3 coils in the motor here. And these spin like this, and the magnet spins the other way. So I think that's pretty awesome. Even and especially because it's I mean, they're so close together and producing such a big field that they're in series, so it's producing one big field. And you know, it works really well with the rectangle magnet. And it'll spin because I've got these bearings in here. So you got the big bearing with the 1/2-inch hole, and you got the 1/2-inch bearings with the 1/4-inch hole. So it'll spin on a 1/4-inch shaft, but I've changed it to a 10 centimeter, or 10 millimeter, my bad. I needed a thicker shaft. One that wouldn't like buckle under the weight of the magnet. Let me get one of those magnets. So what I'm going to do is I'm going to make a casing to encase half of it, right? And then I'm going to make the 10 millimeter hole on the end here and stick the rod like in the center. And then do the same thing on the other side with the rod in the center. And boom, you got this magnet in the middle. And it'll spin like really good. You know, I just got to make the hole 10 millimeter. And I got to get the bearing to fit on a 10 millimeter. Alright, so to give you an idea of what that is, 10 millimeters is right here. And I already got the fit right on there. And then it'll spin nice and smooth. So that's awesome. So I got these Neos. I got 4 of these. I gotta I gotta get the other 3 out of the rotor that I put them in. These are awesome. Pretty strong. And see, the way to get this permanent thing to work the best is to like back it out so that all the forces are right on the fringe. But that ferrite's got to be a little bit closer than the magnets. Yeah. So, I don't know, in my opinion, this is a win. It can be, you can break this down by segment, and you can put it on each magnet if you want to. And I think that would add to a lot of push in a certain direction. Each magnet at 30 degrees at 14 inches diameter is 2.5 inches apart. So I think that's awesome. From the middle of this magnet to the middle of this magnet is 2.5 inches. It's a lot of space for switching, for whatever you need, really. Sometimes it's good to have them closer together, and I got one closer together too. This is another 12 magnet rotor, 30 degrees. They're like right next to each other because it's in close, about 8 inches. Pretty awesome. And you can arrange these ones north, south, north, south. Alright, so this has been in the family for a long time, man, like really long time. My grandfather, he got it from Egypt, and I believe in World War II, just before World War II. I believe it's like solid brass. It's copper, heavy brass. You get a little bit of just, oxidation in certain spots, but not all over the whole thing. This is very brass. And it's got a little story on it. I'm pretty sure it's just a souvenir, but I think it's awesome. They also had a papyrus on their wall. The one about weighing the heart. The heart and the feather. And if your heart was heavy, like something bad happened to you or something. I forget the actual story, but it was pretty neat seeing all that stuff. Egypt is in the blood, not by DNA or anything, but it's like I like it just as much as my grandfather did. Yes, absolutely. Here, I want to bang it with the aluminum screwdriver and see if we can't get a nice resonation on it. Now let me flick it with my finger. That is awesome. How's it going, society? Society of High Sciences. What's up, man? How's it going? All right. So like I said, with this one, with the rate that it moves, we could definitely pick up both eddy currents and EMF and BEMF, you know, you can get both. You might as well collect both. Ah, sweet, man. Glad you're chilling here, man. That's cool. Thank you. And thank you all for coming by. Please consider joining up. You got several kind of memberships. Student membership is the $2.99 deal. And I'm just getting the word out. So what we have going on here with the SSG and this blue coil, this extra coil here, is hooked up to a bridge rectifier and then tied directly into the output of the SSG. And because we got diodes on the input, or the output, and just they're both on the output, that energy will be funneled into the battery that's being charged at that particular moment. So let me see where we're at. I've lost, due to loss, I've lost like 0.11 on each battery so far. But I think if I make that new coil with the super inductance, you know, like a 24 or 32, fill up a whole pound bobbin with 24 and 32, that will be a lot of turns, and that'll be like a lot of inductance. So right now we're at 12.87 on this battery, and 12.85 on this battery. I think we're using just a little bit too much. It's been going for 24 hours basically so far. I've switched it to 10-second swap cycles, so we got 20-second cycles. I'm currently using the power swap relays. I'm thinking about changing over to these relays. They're latching relays. But I gotta figure out how to hook this side up. I mean, when you look at it down this way, it looks like a positive and a negative side. But I need to make sure that's right. I mean, that looks like the only way you can logically hook that up is through positive and negative. But 10-second cycles are helping out quite a bit, actually. So I need to get transistors. I mean, this is literally my last transistor. I did quite a few experiments in the last couple days, though. All right. So does anybody want to see my 50-turn 4-filer 32-gauge coil? I mean, the only way I can hook it up is with the switch here. we'll just check out our, it's 11.4 ohms, 32. I'm willing to bet it's about 150 turns. And it's going to get hot if this thing decides to stop. So wow, that's moving at quite a nice pace. All right, so I really don't like these little ones, but it's just laying here, so I'm going to use it. It's because I stepped on them. All right, let's bend it in. Oh, we clipped it right off. Huh. Dang. Yeah, I'm going to try and find... one that isn't messed up. All right. Let's see. All right, we're at 100 milliamps. It's just a nice gentle push too. Got my trifocals on. Oh, this isn't that important, really. 12 volts. Yeah, I don't know. Ooh. This one or the little one? Yeah, I figured it out in the light, in my output. When there were more amps, the light would be brighter than if it was just voltage or low amps. And so you can tell like where the power's at, but in proportion, kind of, I don't know. Anyway, there's not a lot of power in this coil. It is designed to go extremely slow. It's literally like 150 turns spaced out for that whole bobbin right there, and it is 2 inches long. Trying just to get the switch to touch, and like stay on, so I can make this a permanent magnet basically. Here, let's see. Not hot. It's not hot yet. I had a reed switch lying around here somewhere, like a real one. All right, so I'm not gonna do this right now. The switch is misbehaving. I'm gonna unplug this coil again. There we go. That's good. All right. So this pulse motor in the middle is at 10-second intervals. It's doing a relay swap with the two batteries there on the end of the table. And what it does is it swaps the input and the output to each battery. So the battery's only hooked up once, and the input and the output is hooked up twice. So first 4 pins go to input and output. The next 2 pins go to the power, and then the last 2 pins go to this timer over here, which is set to 10 seconds. So every 10 seconds it's going to swap from being one way to another. See, so you spin it, and you get the wheel, you get the aluminum disc spinning one way, right? And then you stop and you spin the other way, like that. You're getting the most eddy currents when you're going in opposite directions. But it won't stay going like that. You have to like get it going, get the wheel going in a direction again, and then stop and spin the other way. And then they go through the roof. It's like, if that's what your objective is, to get eddy currents, that's how you do it. With the magnet and with the magnet and aluminum disc. I'm talking about this way, with just the permanent magnets and the aluminum disc. There's a lot better way to get them with electromagnets. But I'm talking just with the perms. I'm not sure. I think volts is 1.5 an amp to 1 amp or something like that. Something like that. And then, you know, fast, and then the torque. Well, I don't know. I think, isn't torque kind of when it's based on like a pulse motor, how fast you get to where you're going, not necessarily what that number is. I mean, I don't know. So to answer your question, Society of High Sciences, I haven't given it a second thought. But I do understand, like, the more RPMs you get, the less torque you have. And I understand this as well, though, like, when you're, and I ask this question, when you're rolling a coil up, and you want high torque, what gauge do you roll your coil? Is it going to be like a 32 gauge coil, or is it going to be like a 20 gauge coil? Which one is it? And then of course, the bigger the coil, probably the more the bigger the pound. You know what I'm saying? It's going to pound harder. It just takes a while for it to get there. And I'll tell you what, man, this little 50 turn coil that I made, it's awesome. You wouldn't expect what comes out of it. You just wouldn't expect it. And I mean, there's literally, you just take one 50 turn strand for your drive. And then you've got either an extra strand or 150 turns for your trigger. Because you got to have enough. And even these magnets at, you know, however big they are, 40 millimeters by 20 millimeters, they're big and they're powerful. Even with these magnets, it doesn't always work out. Totally forgot what I was talking about. Oh yeah, having enough power going to the base so you can trigger your motor. I mean, even with these magnets, you'd have to whip it pretty hard at less than 100 turns. I think I could probably get it at 100 turns, but I do 150. I just have a 50 turn drive strand that you get it up propped up on a magnet like this one is right here, and it'll go and it'll continue to go. Like, it's weird. It's not easy though. It's not as easy going as, I mean, it's exactly the same, but I just, like a 30 gauge and a 20 gauge, you can anticipate what's going to happen. Like this one is a 30 gauge trigger with a 20 gauge drive. I got a 22 gauge strand in there too, but it's wrapped into the 20 gauge as a drive. Now what I could do is I could hook it up like this coil and collect the energy off of it and funnel it into the battery as well. But even with doing that, what I mean is by putting it through the bridge rectifier. But even with doing that, the 20 gauge strand alone will spend more energy than this coil and that coil added to the drive. I don't know why, but that's what happens. And it's all based on how fast the rotor's going. Pretty much. Because the faster the motor goes, the more energy this one's going to generate, and the one in here is going to generate. But you do get a little boost, like a transformer boost, from the 20 gauge strand to the 22 gauge strand because they're wrapped parallel in the coil. And it's just kind of, they're separated, but at the same time they're really, really close. So instead of getting like 5 volts, you get 8. Okay, so you get a little bit more voltage just for it being on and in the same coil. But like if I were to separate the 22 gauge strand from the 20 gauge strand, we would immediately be drawing, even with the 460 ohms, a lot more amperage, a lot more capacitance from the batteries. What I'm saying is these numbers will start to go down faster. And see, here's my little bridge rectifier. And I got it all set up to add the 22 gauge strand. And you know what? I can stop this thing and change rotors and all that. All I have to do is make sure that no energy gets drawn from the batteries when I'm doing that. Because it's really, the timing is all about how long the batteries are going to last. I mean, I'm not going to do that unless I really, really want to. Because I felt like this was a good choice to start going forward. I will probably try and figure these out though, because that'll save me a lot of energy. But yeah, it's still at 12.88, 12.87. You really haven't lost any energy yet, and it's been constantly going. That's awesome. So I might just leave it. Torque, you want to know torque? How would I measure the torque? I don't want to stop this thing right now. This is a relay swap, and I'm trying to see how long 2 batteries is going to last. Or are we talking this one? I wonder how I could do that, like right now. I don't have any string. I don't have any string. I've got wire. I've got stranded wire. If you're talking about this one right here, I can break it down for you. I don't know any formula for torque, and I'm not about to bust out my trigonometry book. Okay, so all magnets are facing south out. All right. Then there are 1, 2, 3, 4, 5, 6 facing north this way. So they're attracting. Then you got the ferrite magnet. Or it's not a magnet, it's just a ferrite core in the center here. And it's doing what it does. It attracts, but it doesn't pull. It just attracts. So it's different than putting 2 magnets together that are opposing. It's like half the strength, okay? And then we move on to this stack of magnets, which is, let me see here, 2, 4, 6, 8. So there's 6 on this side attracting, and there's 8 repelling. And there's a ferrite core in between them. I'd say neither one of these motors has any torque whatsoever, like none. We can say that. If I stick my finger on this thing, it's going to stop. But it's not supposed to do anything other than move, generate electricity. Yeah. Have a good time. Bye-bye. Awesome. Yeah, I wish I knew more about torque. And I'm sure if we hooked up more of these stators that it would have more torque. So let's just say the torque is very low. Now, I'm planning on making a coil a style that I haven't made before. Usually I make them kind of small so you get bursts of like strength, speed. But I'm going to make a bigger one that it's going to take longer to get up to its potential. And see if we can get more torque that way. I think that would be worth a shot, and I want it to be so I'm using 24 gauge and 32 for the trigger because I want it just to brush past this thing and get going. I don't want it to have to put much momentum into it. And the reason this is working the way it is because of the spacing. The magnet comes in and then is passing the ferrite and is being pushed out all within pretty much the size of the magnet. I mean, that's not exactly right, but it's kind of the general idea. But I had to use what I had, and it has to be like a certain strength. So if you tilt them, see these are rectangle magnets. So one side they'd be longer and the other side they'd be taller. And right now I got them both being tall. And I just switched it from being flat, from the repulsion side being flat to it being standing up. So, if you're wondering how much torque is in my hand, a lot. Okay, so this could be all from my hand, but as you can see, it's slowing down as it passes the ferrite core. That's not what's going on here. I'm intrigued, so I'm enthralled almost by how simple it is. I don't know why it isn't satisfying to see it move like under a force that's not yours. And I mean, if you did all the math and you did the math of the magnets on magnets and included your hand, it would probably all even out. But you got to do this math too. You can't just do the math of your hand and expect to get the answer. You gotta do all the math of the stator on rotor dynamics here. It's all magnet math. So yeah, I figure that out of both of these, I'd say the big one has more torque because you can actually see the force of the motion being pushed, pulled and pushed, but it's all a percentage of what you put into it. So, but it works. And if you take this out completely, it'll probably move and spin faster and farther than if you have it there. But you can obviously see that what it's designed to do is happening. because it slows down almost to a complete stop and then keeps going. I mean, eventually it's going to stop because it's everything does. You're going to run out of the juice that you put into it. Whether it be unlatching something, it doesn't matter what it is. Well, you start the motion and the motion will continue until the spark is gone. And so all the math that you would do here is going to say that it's going to spin this much fewer times because of the friction and the fact that it slows all the way down. I mean, we're going to take it out just for right now. And now we'll give it a little spin. It's already moving faster than it would, but there's no interaction. There's nothing going on except the spin, and that's all right. I like that. But I'm gonna do like a colossal spin real quick. Oh, I had a prop. Little mini breadboard. All right, there we go. So with that, it's going to slow down like faster, but that's not what I'm looking at. That's not what I'm looking at. I'm looking at if my frequency hypothesis is correct, that it doesn't matter how fast this is going, this will have that effect on it at any speed, any frequency. So, I mean, like if you were going to use it as a booster or something like that, you could put it on there and it would boost all the way up to max Q. You know, it would give you more. I mean, if that's what it does. I haven't quite decided yet. I think it's more of a break. So it's more of a resistance. So you go all the way up to max Q and it keeps you stabilized. I don't even know if that's what it does. Can't really like pinpoint actually what's going on. It's just like throwing the magnet, basically. Brings it in and throws it along. But every time it passes the center here, it basically stops, like pretty much. When it's going slow. I mean, right now I can't really decipher. I know it's happening. I don't know whether, you know, what to make of it right now. Alright, so if I was going to measure torque, what would I use? Kick it into overdrive? There's no power. Let's see if we can do it. A little bit. Oh, that's alright, man. That's okay. It's all good. I think that this has been a great live stream. I think it's been really, really good considering I only have one transistor that works. Right now I'm testing a permanent magnet stator with a ferrite core basically held in place here. The only power that I'm using on this wheel right now is my arm. So, I mean, it does have flywheel capabilities, so it's kind of hard to measure it, but it's easier to measure it if it's going slow. What's exactly happening? I just haven't decided, you know, what the practical application would be, if any. So it looks like it didn't want to go all the way around, but it did, at least once. And that's good for what I put into it, considering how much magnetic interactions is going on over here. I mean, you really got to work with permanent magnets to know what I'm doing here. There's no power in this right now. I mean, hopefully I can change that. I gotta find a transistor though. I'm out of transistors. That's a sad fact. I got one that works and it's in my SSG right now. So this is testing the permanent magnet stator. And it is more of a flywheel than not. The magnets on the edge of it are very heavy. It is a little bit hollow in the center, so it's not as heavy as it could be. I mean, it's 14 inches. I would have had to use like 2 rolls of PLA to make that 100%. But I would have liked it to be 100%. So there's a maglev underneath this thing. And then there's one on the bottom of the rotor. And so what I did here is I've got 14 magnets. I got 6 over here that are pulling. And I got the ferrite core in the middle. You all know what that does. It's attracted to the magnet. And then on this side, I've got 8 that are repelling and a little bit closer. So they get pulled in, they get pushed through the center, and then when it comes out, it gets pushed. It literally gets pushed a little bit. So right now it's going a little, you can kind of see it happening, but it's going a little fast actually for you to see it happen. It could be a little bit better in regards to the spacing, but the spacing is, you know, it's basically the size of a shim. You got your metal. This is a shim right here. And then you got your two staggered stacks of magnets. Uneven. This would be considered an uneven stator. This is not equal on both sides by any means. The uneven bars. Oh, here it is. Maybe this thing will still work. Maybe we can kick it into overdrive. Let's see. I hooked this up right the first time. Perfect. Hmm. Oh. Yeah, something's not right with it. Yeah. Looks good, but it's not. That's all right though. Maybe we could get a different coil out here. Let me look. Do this 24, 32, 32. And we'll use the homemade version of the switch. wish I had more clips because I gotta use this. All right, we're nearly there. I'll get it. Man, this is. So I need to get something to set this thing on, so I don't have to hold it. Just want to find the right spot. See, right there at 90 degrees, on the 12 magnet rotor is the strongest so far. I'm willing to bet at 180 it'd be even stronger. It should go at every magnet, right? But I don't know why it's not the same strength at every magnet. Oh, I got a nice coil we could try. This one right here. This one will go, this is 26 gauge all around. I always used to think this one would sum up to be like a Bedini coil, but just because it's all parallel strands, it's not the same. You need a bifilar coil wrapped the whole way through of probably 26 and 26 or 26 and 28. But this is all 26 right here, but it's like 8 strands. Of 26. So we'll just do one strand of 26 for now. I like this coil with the raw electric. Ahoy! What's up, my man? Christopher Hatton. Alright, so we got 12 volts in this right now. Yeah, that's a good coil right there. So right now we're drawing 100 milliamps. Really awesome. But I gotta glue it down or something. I can't just be holding it like that. So I don't know, man. Maybe we could hook this one up in place of that red one. And where's that core? Right here. This is iron powder. This is like a bunch of iron separate cores. There's like 35% dirt in here too, so so I'm thinking about swapping the big coil out for the red one over on the over here. We're still at the same voltage we were when we started the stream. That's awesome. That is literally the same voltage. But see, without any magnets, once you get it going, it's a flywheel. It just moves. So, I mean, what is it doing? It's moving it. But is it moving it like a motor? Absolutely not. It's not a motor. I wouldn't call it a motor. I would not say a permanent magnet motor. I'd say a permanent magnet motion. Yeah. That's what we were just seeing here. I mean, now that I've said that as basically a disclaimer, I'm not going for perpetual permanent magnet motion. That's not what I'm doing. I don't have enough hair to try and do stuff that, I'll play around though, but that isn't going to be my goal. Oh yeah. So you get it in there close, but it's moving the opposite direction. So we'll let it run in the opposite direction. Now, the cool thing about permanent magnets is just because you're moving it in the opposite direction does not mean that it's going to act as more of a brake. No, it doesn't. It might even move better in the opposite direction. So this is repelling. It doesn't make sense. It's counterintuitive. And then this is attracting. So it should act as a brake in your mind, right? Should act as a brake right here. But it's still the same amount of magnets repelling and the same amount of magnets attracting. Oh yeah, we need to put the mini breadboard. So that's the first thing on my agenda, is to get more transistors. Preferably BCE. From left to right. Now my setup over here actually runs closer to 650 ohms. I got a 460 ohm resistor in there right now. And I mean, the reason that it's going at the speed that it's going at is because I have this coil gathering energy through a bridge rectifier. Now it's not a lot of energy because it's all voltage. And I don't have a cap dump currently. So it'll help out a little bit. Yeah, I'm so excited now to roll that 24 gauge, 32 gauge coil and just go for inductance. That's gonna be fun. I might even swap that. Definitely swap that out. And like I said, I feel perfectly okay stopping that rotor as long as I don't use any energy in the batteries. So it's like the system will never know that it got stopped. I will though. I can stop it. And again, I'm going to try and switch out these relays right here, which require power, a lot more power. It's for these latching relays, which, if I'm right, I should be able to hook up three things. So we got RCS1 and SCR2. And I think the S's go with the S's, C's go with the C's, and the R's go with the R's. You should be able to hook up like 1, 2, should be able to go R1, R2. And I know you probably don't know what I'm talking about right now, but I'm just trying to figure out whether or not I want to even bother being like super duper efficient when I already know what's going to happen. I don't really know what's going to happen. I have hope for different types of things happening, but I do know that these batteries, in any given amount of time, are going to drain themselves dry doing this. And my current objective right now is to find out how long that's going to take. And right now we are at just over 24 hours. Just over 24 hours on. Let me double check that, make sure that's right. Yeah, we turned it on at 4:20 on 4:20. And it is now almost 5:20, so it's been 25 hours. And I mean, the double length, it's 1,460 turns of 20 and 22 gauge. So like, not a lot of resistance. What I mean is there's more resistance there than not. So I could go straight 20, and then like I said, I could hook those two 22 gauge ends to the bridge rectifier and filter that into the output, and that could be fed into the batteries as well. But the 20 gauge by itself sucks out like 600 milliamps to run. You know, it's just too crazily expensive, even with the 400 in there. So you can see it working now pretty good. Yep, somebody wasn't listening. No, this will move. Like I said, there's math that goes along with these magnets, and these magnets and how they interact. It's a whole another group of math that everybody's like either forgot about or wants to neglect or something like that. But and then you cross multiply it with the power coming from my arm, and you'll get like just a few more turns now, and it'll go around like 20, 30 times at this speed. That's how you know it's actually working. But there it goes. That's it. It went back the other way. It's not perpetual by any means, but it is motion. It is happening. So you can't say that it doesn't happen. I guess people don't say that. They say it's perpetual motion doesn't happen, and it doesn't. I mean, mathematically, I don't know. I don't do math. I know there is math to do, but I don't do it. I just experiment. And I mean, literally, you got 6 magnets here, you got 8 magnets here. These 6 magnets are attracting, these 8 magnets are repelling. Then you got a ferrite core in the center. Woohoo! And the only reason you can really tell that it's working is because it basically stops at the ferrite core. And then it gets pushed. It's all it takes is right there. That's it. But, I would just move it the slightest. I get it to go around 1 time. That is huge. That you can get it to go around 1 time just going over 1 hump. But usually I do 2 humps. And that'll get it going for a good half an hour. 40 minutes. But just one, you're lucky if you go around the whole rotation. And when you're playing with the permanent magnets, you'll know when I say a hump, it's where the resistance builds up to this point where you feel like you're going over a hump. And once you get over it, everything moves that much easier. It's what stops this thing from moving every time, that hump. You got to push it over the hump. Why do I feel like I'm trying to explain it to this guy? I don't even know, man. I feel like, anyway, I think this is so cool. It's like intriguing. You would think that, and it's only because it slows it down and then speeds it up again. It's only because you're going over that hump and you can see it. Okay? That's what's so cool about this. You're going over that magnetic hump and it's still going. You're still going over that hump. The stator here is configured to like pull the magnet in and push it along. Pull it in, push it along. Isn't that what all the motors do, except they do it through electricity? Pull it in, push it along, right? So, like I said before, I'm probably going to use one of these red bobbins here, one of these pound bobbins and wrap it up with 24 gauge and 32 gauge. It's the only spools I have with enough wire to fill the whole thing. So, or I'd use 30 if I had more. So yeah, man, donate. Come on down. I need to get transistors. And I need to get more copper. Join up. I always need support. I mean, and I don't care what your opinion is either. You know, you can have an opinion that is completely opposed to mine. I appreciate that. I appreciate commentary that's going to keep me focused on other things that is possible than what I know. You know? So yeah, man, I'm going to encourage people to join up. You know, $2.99. We can talk until the cows come home. You can ask me all the questions. If you want to know torque, give me an equation for torque. How are you going to do that? You need to join my Discord in order to do that. Because I'll tell you right now, I don't think any of these things have barely any torque whatsoever. I mean, just because I can't get the magnets close enough to generate that kind of torque. I did one time. Let me show you which ones I had. Yeah. Because these are literally a soft iron core wrapped a few times with 20 gauge wire. And I got these right up next to the magnets, and there was a lot of torque. I mean, you couldn't you move it with your finger barely. But the problem is that when it's in there that close, you gotta have it really secure. I don't have hot glue. That's okay. That's how I did the other one. But if you look at my table, hot gluing things to this table makes it a literal mess. Not like I mind too much, but I've gotten a lot of comments on it. What's up? Foundation. How's it going, son? And I said that this would work at any frequency due to the size of the magnets. So I'm going to spin it really fast. Well, just that fast. And we'll see if a faster frequency will allow it to, skip over that hump more efficiently. Oh yeah, but I can't wait, really. It's going to be fun. We'll fill this up with 24 and 32 all the way. Yeah, I think I need to be spending just a little bit less than what I am. The relay is on 10-second cycles. Well, it's 20-second cycles, 10 seconds on, 10 seconds off. It's swapping these batteries with this SSG. The output of the SSG is being swapped and the input is being swapped. And we're virtually at, we may have lost 0.1. Let me look. No, we're right where we st we might lose 0.1 in like an hour or so. 0.01, my fault. We're at 12.87, 12.88, and over here we're at 12.85. And now that we swapped off, we're at 12.86. We're gonna get 12.87. Boom. So 12.87 is right around where we're at, and it's where we started at. 12.88, 12.87. So cool, man. We haven't used barely any energy yet. And it's been running for 26 hours now. We are using 20 amp hour batteries. That probably has something to do with it. All right, so, and I'll take the camera off the tripod just to show you how I'm going to set this one up. All right. I just want to give you the aerial of this. So the coils are going to be aligned on the rotor like that. So the actual spacing of the magnets is important. So on the very edge, they're spaced optimally for switching. Way more better than if they were to be like this. Okay, so way out here like this. And then there'll be, the pickup coils can be flat against the magnets though. And they'll be on the other side. All right. And then you use a 1, 2, 3 circuit or an SSG and you spin it like that and it'll start like cutting glass, man. So that's still from my hand throw. That's still moving at pretty much the same speed. So well, it's off. Let's look. See, you got the bigger stack on this side and it's repelling. You got the shorter stack on this side and it's attracting. And you got the iron in the middle here. Now, if anything's, it looks good to me. I mean, it looks just fine. But you would move the stacks of magnets up closer to the rotor and leave the ferrite where it's at. Heck yeah. Yeah, man, that coil is going to be so cool. Oh man, I thought we were actually gonna like be losing power during the live stream, but we haven't lost nothing yet. That 10-second swap really helps out a lot. I mean, it doesn't give enough time for it to drain any, really. This battery has a little bit less juice in it than the other battery. That sucks. But, you know, gotta kind of work with it. Whew, it is nice and warm in here. There we go. So if I use that bobbin, I'll be able to put that iron core right smack in the middle of all that 24 and 32 gauge. That's going to be great. I mean, I just have a feeling like the inductance off of that coil will be enough to charge all these batteries really, really good. And I think it's the BEMF that relies so much on the inductance. And I think that's generated mainly by the amount of layers and the amount of turns. So how many layers are interacting with one another. So I would be willing to say that that blue coil is doing a little bit. It's not just there doing nothing, it's doing a little bit. And that's going through a bridge rectifier. So that's how we're going to do that one. And then if I have any 32 left over, I'll make this one's 13,000 turns. And I think it's the right shape, at least the right thickness for the cube magnets. But I think maybe making like a coil like this with 32, and then how would that work? Like if I made a bobbin that went around like a U kinda, would I wrap it around it like this, or would I go like this? I don't know. Because if I did it the long way, you'd have to have some way to hold the wire in the shape, or it would be kind of pointless. Because if it would just basically end up being a triangle, and when you want it to be a U. So I don't know, maybe. Maybe just cut the tops off, like boom, boom, make it more like a rectangle, and wind it the same way. Yeah, man, that sounds like a plan. So it'll be a little less efficient than a U, but there's no discouragement there. And until you try and wrap a U coil, I think that there is a level of discouragement where you might mess up a lot more. Because you would literally have to have little hooks that you would like hook the wire on to keep shape. And that could get really tedious. There's no way you're using a machine to wrap that. Now, like, a shape that makes sense is a sphere or a pyramid, because you got your grooves. I've seen a bobbin for one of these things. You got grooves in there that you can like put your wire in. Now making a U, I don't see how that might not be easy. I can see making like a serpentine coil in the shape of a U, kind of thing. Because you could have that angle, that serpentine angle that you desire for generation. Be great, but again, you'd have to have little pegs or something to form the wire around the bobbin. But that would be a lot easier than just wrapping it. If you like use a serpentine Litz coil type thing. Yeah, man, I'm so thrilled that everything's working out with the swap so far. So I might make a serpentine coil with this. Heck yeah. That is 100 strands of 38, all wrapped up. This is amazing, man. When did I throw that? It had to be like 10 minutes ago. So this little rotor is literally going to be encased in like a diamond shape, because that's where the most action is, at the very edge of the rotor, because it's only 3 inches. The rotor is only 3 inches, and it's got the ferrite magnets in it. And then I was thinking maybe of an axial flux. Well, what I want to do is I want to use this dynamo. Okay, so real light dynamo. Against this aluminum rotor, so like this, when it's spinning, you know, let me get some light. It's really kind of neat. So it's a dynamo, so it'll work on aluminum or magnets or whatever. So what I was going to do, since it's obviously an AC hookup, was take the AC hookup, plug it into the dynamo, and take it out of the light. Okay, put the light down, and then anything, you shove a piece of copper inside this hole, you clip the outside, and anything that this picks up or generates can be used through the attachment here. That's literally, that's a lot. That's like 5 volts of solid usable energy. But the minute I started losing power, I knew that the coil was wrong. The coil's not right. And I knew that before I started, really, but I mean, it's good. Hello. Let me explain. Let me show you my amethyst spheres. Or I have one amethyst sphere and a fluorite sphere. This is really awesome. Look how dark that is. That is phenomenal, dude. That is awesome amethyst. It's a gemstone called fluorite. It's got the green. Really neat. That's still going. That's awesome. That is literally just trucking along. All right. So the next time I go live, I will have that coil made. Hopefully it'll be tomorrow or the next day. I know I keep talking about it, but I mean, that's quite literally the problem with what's going on right now. Why we're losing power to begin with is because we're not generating enough. And I mean, if you got the right coil and you put 12 volts in with 500 milliamps, then you should get more than that out of it. If you got the right coil, or at least that much. You might not get the 500 milliamps, but you'll get way more than you think you will. Now I had a coil right here, this coil. This is similar to what I'm going to build. This is a 24 gauge and 32 gauge, but it's a trifilar, so there's two 32 gauges. 777 turns of all 3 of those. So I know just by looking at this one that it's going to be, it might be closer to 2,000 turns. And I'm like thinking to myself, God, I hope that works. Because, I mean, literally I can put 2.5 pounds of copper into it, just rolling at 24 and 32. No. Oh, maybe. Because it is a pound bobbin. That doesn't make sense at all. So, Yeah, I don't know. I think I could fit 2,000 turns on there. I really do. Because when it gets out to the outer edge, it's way more material per turn. So maybe I'm talking about the tonnage that it'll weigh. Or maybe I should get it. No, that's fine. See, I don't know exact. All I know is that I'm gonna fill this whole thing up with one strand of 24 and one strand of 32. So it should be like 1.5 pounds in the end, because the pound ones that you buy aren't all the way filled in. This is a permanent magnet stator experiment. We're experimenting with this. It's a permanent magnet stator. You got a traction here. You got a ferrite core in the center that's yoked with aluminum. And then you got 8 repulsion magnets. And then over here, we've got a relay. It's been running since 420 on 420. That's about 26 hours, 26 and a half hours now. We barely used any energy. We used 0.1 on each battery. So, well, yeah. So we used 0.12. So 0.12 of a volt so far on each battery. And that's why I'm talking about making a new coil, because I'm pretty sure we can get better results than that. That thing is still moving. That thing is still moving, and that's been literally like 25 minutes. No. I just explained. I don't know, man. Maybe. I mean, I feel like I just explained what was going on. I can explain it again. These are 12-volt batteries. Okay, 20 amp hours. That's what we're using. That's what we have. That's what we got. And then let's see how fast this wheel is moving. $20 divided by 4. 500. It's moving 500 RPMs. That's fine for what we're doing. I'm just seeing how long these batteries are going to last. So it's a battery swap. This one's charging, well, this one's driving, then this one's driving, this one's charging. And no, we're not storing the energy, man. We're spending it right now. It's spending very slowly. But my objective is to see how long these batteries are going to last. So I'm going to make a better coil and we're going to see what happens. You know, they have good setups online. You can get them for like $3,000. 48 volts, and they'll power your house for ever. They recharge via solar or any other method, and is a good addition to your house. But that's not what we're doing here. I mean, it could, if I get it right, work like that, and the concept might be the same. But these are 12-volt batteries. Anything faster than that, and people start freaking out. There is no circuit for the flywheel. And I have the SSG input-output swap over on the other side is on my page. So if you'd like to, see the schematic, it's on my page. It's on my posts. It's not that great. I mean, it's good enough for me because I know what's going on. But it's basically the same. It's a good layout of what's going on. The only thing that's happening here is all permanent magnets. There's no circuit over here. Let me show you. My bad. I didn't see the camera being so far off. There. That's all that's over here. See, these are not hooked up. These are not hooked up. It's just about the core in the center. But yeah, for the relay swap, I got the circuit on my posts. It's all up there, so I encourage you to go and check it out. If you want to see a schematic, I'm not doing any of that normal stream stuff. I don't do that yet. I don't, just not at all. This is what you get with me right now. I'm just video blogging myself. And what I do is experiment in real time. Now, I don't have anybody helping me out, but if somebody could help me out and post my schematic. Watch your mouth! Just kidding. And we were having such a good day so far. But now I gotta take the camera out of here and erase some stuff. I'll just hold on to this for a while, just in case he's not done. So I say I need help, and then Sam Gamgee comes up on the frickin' chat with the troll. That's awesome. So if anybody was here before, I saw me how gently I tapped that thing. It's not really that heavy per se. The outer rim is where all the weight is in those magnets. But yeah, man, that permanent magnet stator on the other side. It works. What am I trying to do? A realistic motion test of permanent magnets, and that's it. So, and right, you can see it. It kicks. It's kicking. It's definitely kicking. Oh man, I can't wait to use that. Not use it, but make it. And yeah, so I mean, I haven't like, usually I'm going really fast and my coils are designed to do that. There's just so many things I want to say right now. I mean, if you haven't been paying attention, that's cool. Oh, I didn't say without force, homie. I never said that. You watched me push it with my hand. I put force in with my hand. So I don't know how to answer that. But it'll keep going. I mean, it would go, like I said earlier, it'll go faster if I just take the magnets away. But you won't get that kick anymore. It'll just be moving smoothly. But I was just demonstrating how these work. What am I trying to accomplish here? I'm trying to prove a point. And I'm proving it. It's not like I'm trying to do anything. I've done it. And here, this is a battery swap. It's not a battery swap. It's an in-out swap. So what's being swapped is the in and the out of the SSG. Okay? That's what's being swapped with the batteries. So if you know how a relay works, I can explain that to you. So I say past each magnet, there's less and less force that I applied with my hand. But because the magnets are there, you can see the force broken down. Once it comes up on the magnet, you can see it kick. Once it passes the center there, once it passes the ferrite core, you can see it kick. Because it's being repelled. Without the ferrite core being there, it won't work. Because the magnets will be too close together and you'll stop. You have to have the two stacks separated. They can't be together. I mean, if you talked a little bit less like a troll and acted like you were maybe a little bit more interested with what's going on here, you're just interested in what, debunking? There's nothing to debunk here. It really isn't. Yes. It's not what's making it rotate. Well, maybe it is. I don't know exactly because I did move it with my hand, right? But you know, eventually that should stop, especially with there being this many magnets right here. Okay, especially with there being this much magnetic interference with the rotor, this should eventually stop, and it will eventually stop. But I mean, it should have stopped a long time ago. But they're configured correctly. I mean, I gave him a chance, but he's just too much of a troll. No, there's no battery. There's a power supply right here. There's two batteries right there, but they're not hooked up to it. See, it's about to stop, but it's still going. You can even see the principle, you know, displaying itself right in front of you. See, right there. That's why there's not enough force to keep going. And of course, that happens, that everybody knows about that. But what they didn't know was how long this was going to spin. Watch me, I'm just... Yeah, and whether that's a hindrance or a help, I don't know. I can't make it up for myself whether it hurts or helps. But if we take it away, the magnets, all the way away, and we put it over here. See, now there's no kick, and it's moving a lot faster, and it'll move like farther. But what I was just trying to prove is that that stator configuration does motion. Not a motor. I'm not saying it's a magnetic motor. I'm saying it did the motion. No, no, no. Oh, you mean from the magnet? The only electricity going through, it's not shorted. If that's what you mean. If that's what you mean. The only electricity that would be going through it is that generated by the magnet, but neither one of these ends are connected to anything. So. See, but now that I moved the magnets away, it's actually picked up speed. And that's because of its flywheel capabilities. All right, that will eventually stop. So, you know, we'll just stop it. The only reason that the coil's there at all is to hold the ferrite in place. That's the only reason it's there. I thought it was pretty cool setup, but I mean, like, if we want to get anal about how much electricity is coming out of 11.4 ohms of 32, we can. We can do that. I would actually love to know. So maybe if I hooked a multimeter up to these strands, we can see if any electricity is being generated or quote unquote used. Actually, I don't want to do that. I got both of these hooked up to my relay right now. So the only other way that I could get the ferrite core where it is to print another bobbin, put the ferrite core in there, and like, I mean, if anything, that aluminum that's yoking it would be a break, like a massive break. Batteries are being charged with the small wheel. So the big wheel is permanent magnet experiment, and the little wheel is electromagnet experiment. And I mean, if you get it at the perfect distance, and positioning is everything with permanent magnets, and probably electromagnets too, but if you get it in the right position, I mean, it'll go obscenely long amount of time. At this speed, you know, without momentum. You want to hear about the electromagnet setup? Okay, I'll break down the coils, the magnets. Magnets are south facing out, and north is all jumped up in the middle. There's a toroid on the bottom facing up. North is facing up, so it's holding it right there. If I can get a good shot of it, it's just kind of resting on that toroid. And that's iron infused PLA on the bottom too, so it's kind of working as a clamp. Anyway, that's the rotor. You got 13,000 turns with 32 gauge hooked up to a bridge rectifier that is hooked up to the output of the SSG circuit. This coil right here is 20 gauge, 22 gauge, and 30 gauge. 30 gauge is the trigger hooked up to the SSG, and the 22 and 20 gauge are hooked up in series, also hooked up to the SSG. I'm using an NPN transistor. I do not have a schematic for the SSG. I recommend going to K Energy store, and you know, he knows SSG, Hall Effect, Peter Hall Effect X. He knows SSG. I do not know. Well, I can kind of backwards engineer it, but I'm not going to take that apart. I just take it for granted at the current time. All right, so relays. You got 1, 2, 3, 4. So 1, 2 is hooked up to the input on relay 1, and 1, 2 is hooked up to the charge on relay 2. And then the charge is hooked up to 3 and 4, and drive is hooked up to 3 and 4. All right, so those are the two things that are swapping, the in and the out. Now the batteries are hooked up to 5 and 6. Okay, so each relay has its own battery, basically. And then this timer over here is hooked up to 7 and 8. So it flips the two relays at the same time. Oh! All right, so, and it's tilted. Everything on this table is on a slant, okay? And I can't fix it right now, but I have a board right there to fix it with. But you see how it's all dipping in the center there? All these experiments are prejudiced to the board that it's resting on. They're all slanted. Okay, so I mean, if it was perfectly flat, we'd probably get a really good idea of what's going on. But right now we can only kind of see it. Well, James, he saw it. We got the 12-volt batteries at 20 amp hours. And look, man, I mean, seriously, this is where we started off when I began the stream 2 hours and 42 minutes ago. We haven't lost any energy, like, at all, really. I mean, we've lost a little bit, but it's like minuscule. And that was due to the fact that I changed the time sequencing to 20-second cycles. 10 seconds on, 10 seconds off. You can hear these things like clicking every second or so, or every 10 seconds. But the objective for the relays is to switch to these. They're latching relays, because every time it's on, the power supply is hooked up to the relays right now, and it takes 350 milliamps to run the relays. And you got to run it 10 seconds constantly, so you couldn't run that on a battery without a resistor of some kind. Yeah, I got to make a better coil, and then for sure we can generate 30 volts. Right now I'm just monitoring the batteries. Currently, though, the output is somewhere around 8 with this coil. And that's why I added this coil to, balance it out a little bit. Because 8 volts is like nothing in the grand scheme of things. So when I make my 24 32 gauge coil, it's virtually going to be the same size as this one, but it's going to be all 24 and 32. Oh man, that coil is gonna have a lot of energy that it's gonna produce, and it's gonna be a little bit quicker than say a 26 coil. It's gonna be a little bit more draw, but just a little bit because it goes 26, 24. So I don't know. I think it's gonna be all right, and it's gonna take a lot less momentum to get it started because the 32 gauge at that rate is gonna be enough coil to just have a magnet pass it and it'll start up. But maybe. Mohammed, I believe that with the proper coil, this output could be 30 volts or more. But right now, currently, I can't. Let's see here. I'm gonna clip these to the output, and we'll see what we're making. Oh. currently commingled with the battery. It looks like 12.9, or that's the reading on the battery, I'm pretty sure. No, it was the battery plus some. So, I don't know exactly. But it went up to 12.9. That much I'm sure of. Let's try these. So off the bridge rectifier. I don't know. It looks like we might need oh, it is a bridge rectifier, right? Dude, man, language, homie. Watch your phone. Man, and it's it's all the Americans that got the potty mouth, I'm telling you. I didn't even read all that. All I wrote, the first line was WTF. I'm like, okay, goodbye. So I'm pretty sure that the only reason we're getting readings like that is because it's going directly into the battery. I mean, seriously, you're not going to respect the fact that I'm doing this at all. I mean, just bits begets bits. Really, man, I can't let you just chill if you're gonna. All right, so since I was so rudely interrupted, this is a relay swap. This is a battery swap relay that I've used absolutely no energy, or 0.01, maybe 0.01, in the last 3 hours. So I think that's pretty good. It's a pretty good coil, but it can be better. So we're going to make 24 and 32. And that thing is still moving since the last time I pushed it. And that's a long time ago. So the only way to get any like solid measurements off of this stuff is to take it apart and measure it differently. But I've gotten some pretty interesting readings off of it doing it differently. But all this is like, let's see if we get any oscilloscope reading off of. No, because it's a battery that I'm monitoring. See, so we got the little straight line here. It looks like it's below the line, which is nuts. So I don't know if this is... I can even get an oscilloscope reading off of a battery. I don't think it's something I should be even bothering with. All right, so to break it down one more time with the relay here, we got an SG input and SG output. We got the SG output hooked up to both relays. Okay, they're hooked up to both relays. And then the input is hooked up to both relays, alternating. So input, output, output, input. Okay? And then each battery is hooked up to its own relay. And then the last two pins on each side is hooked up to the timer, which triggers the relays at the same time. So it's like the batteries flip-flop. And at 10 seconds a pop, it's working really, really good. Thanks, Mike. Thanks, Mike. 10 seconds. Who would have thought? I was doing it at 30 seconds prior to this, and it would just run out too fast. It wasn't balanced right. Now, granted, we're losing, even though we can't see it, but it's like 0.01. It's very little. And it's because of this SSG circuit. K Energy Store. I recommend you buy something from him and see what you can make out of it. I've made very good use of this. He is a very knowledgeable person. He does charge for his knowledge, though, so consultation price is well worth it. I would imagine. So, you know, basically my swap goes to the SSG, not to what's in the SSG, if you get what I'm saying. In my schematic, it swaps to in and out of the SSG. It doesn't swap in and out of what that looks like in schematic form. I have no idea. I don't read or write schematic, really, at all. I don't. And really, it's like this goes to this, goes to this, goes to this, goes to this, goes to this. And that's how I built this. Connecting the dots. Besides, when I see it all at once and it isn't moving at the proper frequency, I can't see it at all. So 500 RPMs is pretty much all we need to keep this going until I build my other coil. All right, we're going to whip it. Oh, man. All right, so, yeah, man, that's basically what it is. I hope this thing goes for a month or so. At the rate that it's going, it should go for a month or so. But I don't know if it's gonna like go the battery, like if it's gonna drain at the same rate the whole time. I don't know. I don't know what's gonna happen. I do know that they will probably eventually die, especially if I use the same coil that I'm using right now. So, but yeah, this is what I'm gonna make it out of. $24 and $32. Heck yeah. So this is, I don't know, I'm having a lot of fun. We're gonna, the axial flux one over here in the stand over there, very axial flux. We're gonna have the 2 drive coils. We're gonna have 2 pickup coils, and then we're gonna use the contactless dynamo. And yeah, we just need a coil that's going to generate a little bit more electricity and maybe give it a little bit more speed. So I think the 24 gauge strand will be that much better than the 20, that much better than the 22. The only thing that might be better is 26, but I don't have any money to buy 26. I have 24 and 32. So, yeah, I'm happy with that. Besides, I think 24 is going to work better in a lot of ways. And if I make it a tri-filer coil, then I could like put 32 in the drive as well, or make another coil out of it and add it through bridge rectifier. There's lots of things I can do, but making that coil is going to be the first thing. It's going to be so fun. And then watch it not work at all when I hook it up. Watch it be way too long. But I don't think that's how it works. I really don't. I think it's going to be great, though. So awesome, man. I didn't think that it would be running this well. And what we're doing is we're balancing the power of the 2 batteries between the dual input and the dual output. We're not trying to generate a bunch of electricity. We're not trying to do that. We're just trying to balance them. And they're pretty balanced. Don't want to mess that up. Wow. Thank you very much, ladies and gentlemen, for hanging out with me. I really appreciate it. Now, I did dial in to this coil right here that it would need 650 ohms. And right now I only have 460. So, but I mean, it would slow it down even more, and I don't think I really want that. I just want the coil to make more electricity at the speed that it's going, or maybe even go a little bit faster. But we'll see what happens. But right now I'm just going to let it run because I don't have that coil made and I wouldn't want to stop it for no reason. But when I do stop it, I turn off this power first and then I unclip the negative of both batteries and then I can do whatever I want to change it. But right now, man, I feel like just letting it ride until I at least have that coil made. So what's going on this side over here with the big 14-inch rotor at 12 magnets, 30 degrees of separation at 14 inches is 2.5 inches. There is 2.5 inches of space between each one of these magnets. So quite literally, if you add all this together, you got about 2.5 inches, maybe a little more. So if we do this, so we do that, now it's about 2.5 inches. So the space in between the magnets matters just as much as how big the magnets are, especially when dealing with the permanent one. Heck yeah, man. I'm thrilled with it. The results that I get, I'm happy with them. All right, so I'll break down the stator real quick. You got 6 magnets repelling, or no, attracting. Then you got the attraction of the core in the middle of this coil. And then you've got the 8 repelling. So attraction, attraction, repelling. Attraction with magnet, attraction with core, repelling. And that's awesome. So as soon as I get my hands on some new transistors, we can see how fast this thing really goes. Actually, we're just going to make it until it starts rocking everything, and then we're going to shut it down. Because while it's going slow, it's pretty smooth. But when it gets going, it rocks everything. Good thing for me, it doesn't have to go very fast to generate. Well, I literally had 2.68 volts, less than 100 milliamps, and this thing was generating enough electricity to light this LED over here. That's 100 watts. And it was bright. It was lit. It wasn't just like partially lit, it was lit. And it wasn't going fast. They're strong. There's 12 of them. And in order to light the light up, you just need that AC electricity from a coil. It was going probably about as fast as it's going right now. Awesome. And then there's this, which is virtually a cap bank. See, there's 4 AC caps on this side, and then there's 4 rectifiers here in the middle, and then there's 4 rows of 5 capacitors apiece. And all that connects, but all of it's separate too. Like each row, there's 1 AC cap, 1 rectifier, and then there's 5 caps all in a row. And there's 4 rows like that. Really, really cool. All right. So I'm gonna have to call it for the day. I gotta go eat. But actually, I don't think I'm gonna eat. I think I'm gonna walk. All right. So yeah. I'm going to keep you posted with all the new coils and stuff. I'm going to see if I can get my hands on some more of these magnets and make more stators like this. See if we can improve torque at all. And have it like spaced out, like have 6 of them on the 12 magnet rotor. See what happens. I think with the proper positioning, we get, 6 little pushes like we're getting with this thing. All right, but hey, yeah. Have a wonderful night, ladies and gentlemen. Peace out. Have a great day. Thanks for coming in. Bye now.